I'm Hussam Jouhara, Professor of Thermal Engineering in Brunel University London. I'm also the head of the Heat Pipe and Thermal Management Research Group at Brunel. My project is about designing, optimizing, and testing a heat pipe-based waste heat recovery system from radiative sources that can be used in the steel industry to optimize and reduce energy consumption and reduce the environmental impact of these fuels in the process itself.
What is the vision for this project?
My vision for this project is to design, optimize, and test a full-scale prototype that can be installed in a steel manufacturing process and can demonstrate also how this technology, the heat pipe technology, how it can be used to reduce fuel consumption by recycling radiative waste heat back into the process and hence reducing the emissions from the process itself. In addition, as a university, obviously, the other goal is to disseminate the information and the knowledge that we'll be achieving during this project to the wider community through articles and presentations in international conferences.
What have been the biggest challenges so far?
As of any technical project, the biggest challenge is the technical challenge, really, to be able to design the system using correct data. Obtaining correct data is always the biggest challenge here, and especially when we're dealing with radiation or radiative waste heat recovery source. Now, radiation heat transfer is a complex mode of heat transfer, and there are so many parameters that require actual knowledge of the site itself, which has been a big challenge for us to predict. But we have managed to do that through our experience with dealing with various steel processes from other projects. The other challenge we have is the design of the system itself. It requires deep knowledge of various heat transfer and fluid dynamic processes that we have actually overcome, and we are now in the final stages of the design and manufacture of prototype. Perhaps the bigger challenge was non-technical, was to find actually a suitable demo site that we can actually take the system and test it in situ and demonstrate the real value to the end user by actually doing real experiments. And as you know, the time of the year has been quite challenging for the steel companies that we collaborate with, and it was really difficult, especially that the project is only 6 months long. It was quite difficult to get the right approvals and from these companies. So we used our contact with one of our partners from the aluminium industry, who have kindly agreed to allow us to demonstrate the prototype in their facilities using surfaces at similar temperature to what we have aimed for in the steel industry. And that also shows good collaboration among different sectors, which I think will enhance the value of the project outcome.
Are you already making a difference to the transformation of foundation industries?
By actually showing these industries that there are solutions that are capable of recovering waste heat streams that were deemed unrecoverable, actually we have started making this difference. And through our discussions with partners in the steel industry, obviously, and also in the aluminium industry, who will allow us to do the real demo, they actually now appreciate that there is a technology there, the heat pipe technology that we're going to use, that will enable them to do something that will bring value to them and will actually recover waste stream that was really, really difficult to recover. So this is really, in my view, is what's going to make a difference. And it is already making a difference because engineers in those companies are thinking ahead of utilizing this technology and basically implement it in their process itself. So this shows clearly that the project is making an impact now and in the future too.